Welcome to the November 2022 OpenZFS leadership meeting. Looks like not too many of us here right now. I won't make a comment on the meeting length so as not to jinx us, but I don't see any items on the agenda. We have a quick update from the conference, although I think most folks here were at the conference. I had a great conference, a lot of great talks, a lot of great socializing with other developers that I haven't seen in several years. And we're posting the videos now, so I'm getting about one a day uploaded on YouTube. So that content will be available to folks who couldn't attend in person. Other topics or questions?
If possible.
Yep.
Speaking about topics, just like to bring attention to my patch asked for review for some ARC refactoring I started unexpectedly even for myself. I was going to work on uncached prefetch. I was talking during the hackathon, but ended up first digging ARC and stuck there, and ended up refactoring. A few things got ugly over the years through the number of refactorings. So I'd like some people to have an eye on it, because at that point I'm just already fixing unrelated test failures, which are not even mine. So it's probably a good time to take a look.
Yeah, I took a quick look at your description, and you know, it all sounds good. I didn't look in detail at the code yet.
While looking at it, I found a few more oddities around that logic. Separate, but still, for example, right now we are in first order evicting data from host lists, and only then starting evicting metadata. I bet on system with a lot of metadata, our balance between MRU and MFU is heavily biased to metadata. I'm not sure was it intentional or it's another bug. But
yeah, I've seen that kind of imbalance in the past on real systems. I suspect that there's some issues with the logic there.
Just I have a few more ideas, but it's difficult to work on patches on patches on patches on patches. So that's why I'd like this one to move on, and so I could do other things.
Cool. And by the way, Mohammed, I was just responding to your request for a Slack invite. For some reason, your email address didn't come through on the mailing list. So if you could send that to me, send me your email address, then I'll get you an invite to Slack. And that applies to anybody else who's watching or listening later on. If you want to join the OpenZFS Slack, just send me your email address and I'll get you an invite.
Sure. If I could just ask, like, how can I get your email address? I'm not sure it was very obvious how to get it. Oh,
my email address, you can send it to matt@mahrens.org. So like matt@mahrens.org. I'll post it in the chat. Or if you are comfortable sharing your email address publicly, then you can post it on the mailing list as well.
Yeah, sure, I'll do that. Thanks.
Alexander, did you have a chance to look at the ZVol quota PR that we updated? We put the skipping enforcement on ZVols behind a tunable so that if in the future we add the ability to actually adjust the quota on a ZVol, that it will work by default, and this patch won't.
Oh
mess
yeah,
that up.
I saw last commit. I saw that by default quotas are still verified, so I consider it that's good.
Mhm.
At least, oh, at least not bad. So,
Yeah.
Thanks.
Yeah, and the other change that actually allows you to go slightly over the quota in order to avoid, constantly stopping everything and waiting for the transaction to flush has already been merged.
Oh yeah, I was actually thinking, like, if we are already implementing mechanism to allow going over quota, why do we still need the tunable to improve performance? It should already be good, I think, isn't it?
I think it depends how much you're writing, but yeah, it was mostly just to make sure we never slow down unnecessarily on a zvol for some use cases.
But by default, we still honor quota, so it's still for your local use or somebody's local use, right?
Basically. There's enough use cases, especially with lots of VMs or iSCSI stuff on it, where it would make sense that you'd want to make sure you're not slowing down. Because the amount you can go over the quota is purposely kept relatively small, and the amount of outstanding writes could be larger and result in you still waiting. But that's why it's not on by default.
No, I still hope that what I don't remember what was the amount of over quota, but if it's in percent, I think for any non too small,
right,
it should be sufficient or and enough to not slow down too much, but it just looks much less invasive to me.
Yeah,
so I'd be good about that.
Yep. And I think we have a agreement from Brian and Tony and so on about doing the VDEV properties on the root VDEV and how you will access that. Rob will push an update to that pull request today or tomorrow. And then I think that one should be good to go then. And Marius should be able to finish the last update to the failfast one to make the Linux specific tunable or module parameter for setting the mask. And we've changed the dataset property back to be simple, and so that it'll be compatible with something if we add a similar mechanism to FreeBSD.
Oh yeah, I saw the commit just reducing to on off.
Mm-hmm.
I think that's enough for me. I just like to see we use it more automatically, or in cases when we know we can retry or can't retry. I think we use it only in very few cases, but probably we could expand that. Would be nice.
Yeah, likely can expand it, exactly. I think that's about all of the pull requests we have open. We just started working on the forced export one again, so it's not really ready for to get approved to be merged or anything just yet, but we're working on that one actively again. I think, Matt, that will include, based on your feedback, the small semantic change to fail mode equals continue, where we will actually fail out rather than wait on an fsync that's started before we suspended, but then we suspended, and we should fail there instead of wait forever. And likely add a new fail mode equals export that will force export a pool that gets suspended so that it can't jam up any other pools that happen to be on the system.
Cool, that sounds good.
Yeah, as far as I can remember, that's everything I have open.
Cool, thanks, Alan. I see a couple other folks have joined. There wasn't anything on the agenda that I saw in the agenda doc, so it's just open discussion of any questions or topics that folks have. So what would folks like to talk about?
I guess we don't have Brian today, but there's been more questions around when we would be doing a 2.2 release.
Yeah, I think he was conveniently absent last time.
We wanted to talk about that too, yes.
Yeah. Why don't we ping him on Slack?
Okay.
Other questions or topics?
Nice. The other one we were looking at is the per dataset IO throttling stuff that I talked a bit about at the conference. We've got, based on that, got some interest from folks on actually getting that done. And we've looked at a couple of different places where you might implement it. In particular, if it makes sense to do it near the top towards the VFS side, or lower down more towards the VDEV side. The pros and cons to both of those a bit. Obviously, doing it closer to the VDEV side means that really large writes are already broken down into more reasonable chunks, and we have it accounts for the extra things that happen, like the metadata updates that are caused by what the user does, so that those count against their quota. Whereas if you're just at the VFS level, it maybe doesn't. And things like that. But also, once we're too far down towards the VDEV level, how much do we know how this write is associated back to a specific data set to charge them for it? And kind of looking at all of those. I'm just interested if anybody has opinions or experiences to share.
If you look at the, and I don't recall the specific places since I didn't write it, but on SmartOS, this is never upstream because it's per zone, so like a container.
Yeah,
so
there's a pull request where someone ported it mostly to the Linux one. It's like a pull request in the 9000s. I've looked at it. It looks kind of interesting, although it's mostly about ensuring fairness between the different zones, not more strictly limiting a specific zone or data set. And
yeah, I mean,
our customer wants specific limits.
Yeah, I mean, it's not about, I don't think you can set like a specific IO rate as much as you can, whatever the IO rate the pool can sustain, you can divide, proportionally divide it between things. Because it's kind of in this, on a Lumos, there's something called the fair share scheduler, which kind of can work the same way for scheduling between zones or things called projects, or which have nothing to do with CFS projects, but essentially groups of processes. And so it's kind of, I believe it was kind of modeled after that. I'd have to ask Jerry for sure, but that's kind of how it works. A similar idea where it's kind of, a relative proportion to the other stuff. But at least some of the techniques in terms of, slowing, essentially, I believe it basically adds latency to certain IOs to kind of achieve the fairness with the others. So I don't know if at least some of those techniques or bits there might be useful.
Yeah, I think depending on like the semantics that you're trying to achieve, that it might be better to do it at the at like the SPL layer versus at the VDEV or IO layer. Like if it sounds like maybe what you want to expose is like a quota of this data set can't do more than X megabytes per second. If that's the case, then I think you could do it at the SPL layer pretty straightforwardly, because you know how many bytes are being written and also or read, and also you're exposing the megabytes per second to the user. So if there's like an overhead of doing reading metadata, then maybe they shouldn't get charged for that because they don't have really as much control over that. Similarly, like they don't have as much control over compression, like the compression ratio or whatever. So maybe they should be charged for the before compressed or uncompressed size, which is what's kind of easily available at the ZPL layer. But it depends on the semantics, right, of what you're trying to actually implement.
Yeah, like we've even gone back and forth, or if it's an ARC hit, should we charge them for it or not? Because there's advantages to not, they're not actually using up a precious resource in that case. But does that then feel weird to the user where sometimes it's fast and sometimes it's not? But do we want to limit them to as lower speed for no reason? And yeah.
Yeah, I mean, it depends a lot on kind of why you're trying to do this to begin with.
Yeah, especially, if it's partly like artificial scarcity, trying to do an upsell or something to charge more for apps, maybe you want to limit everything. Whereas, if you're just trying to make sure that noisy neighbors don't steal all of the disk bandwidth, then it makes sense to charge for what's actually consumed rather than what's logically consumed.
And in the latter case, like maybe something like what Jason was describing, where you aren't setting up per megabyte, megabytes per second or whatever. You're just saying, this group of IOs and that group of IOs should be kind of like equally-ish weighed.
Mhm.
Because you can easily have two workloads in the same system that where one is like sequential, like, or one is like serial IOs, right? Like do this IO, then do that IO, then do the next IO. And the other one is like issue 1 million IOs all at once. Well, the one that's issuing 1 million at once is going to saturate your storage backend, and the one that's doing one at a time is going to experience much higher latencies because of the higher queue depths. That's the kind of worst case noisy neighbor. So maybe you're just interested in preventing that.
Yeah.
I don't know.
The other part too, if you're trying to specify a certain, bandwidth, the difficulty is, I guess, in terms of you dealing with oversubscription, because even with a given pool, I haven't really done much testing with this, but I'm guessing that the actual quote unquote max bandwidth of the pool is probably going to vary depending on the IO pattern. If you're talking, physical disks, random versus sequential is going to, impact the IO rate. If you're talking, SSD, or if you have log devices in there, that all kind of makes it hard to say, oh, well, this pool can sustain, can do, XIO, megabytes or gigabytes a second of IO, and all even the IO rate. So that's the other thing with, I guess, weighting, I guess, is kind of, I think was probably the other rationale behind at least the approach that was taken. I don't know if that helps any, but
Yeah, I think that's definitely true. And the like if the quota is if you're implementing a quota of megabytes per second, then the issues that you raised fortunately are not relevant to that, right? Because you're just saying like, well, like I'm going to prevent you from doing more than this. Other things might prevent you from doing other amounts of IO, which might be less than the quota. Just like with the disk usage quota, it's like I'm saying you can't use more than this, but you also might not be able to use that whole amount because it's a quota, not a reservation, right? So that's at least implementable. Whether it's what you really want, is, goes back to the use case.
Mhm. Yeah, so we'll have an update on the design as we get a little bit further through it and figure out exactly what we think will make sense for what we're planning to do here. But I think we are leaning towards specifically, basically IO quotas of IOPS and megabytes, and probably doing that at more closer to the physical level, just to account for, what's the actually the limited resource.
Yeah, I think that should be doable as well.
Yep.
More topics. What would folks like to chat about? All right. If
Continue.
go ahead.
Continue the topic of ArcP. There was just coincidence in time. Somebody created issue about adaptive MFU MRU seems broken, and there I written my idea how could we improve ArcP behavior in case where same data they were also should be same time MRU and MFU because they are recent and they are frequently accessed. And right now they are like behaving slightly weird because we move them to MFU, but ArcP is not decreased, so we can accumulate more of MRU data. As a result, some of currently MRU data that left became very, very old, potentially much older than should be. And I think we could improve if we explicitly track buffers which were promoted from MRU to MFU for proper tracking MRU depths. Like we would know that X megabytes of recent data should be kept no matter how much do we promote. That's issue 14.120. If somebody wanna go and comment there. I haven't tried to implement it yet, but it seems not so complicated and makes sense. But maybe I'm wrong in understanding the concept.
Yeah, I haven't looked at that one, but I think like I agree there probably is a lot of weirdness about how like the MRU MFU split works. The way I always think about it is it feels like those are kind of misnomers. At least from how it's implemented, because it's really like one list is things that have been accessed exactly once, and the other list is things that have been accessed more than once, right? So it kind of makes sense how that accomplishes the ARC's goal of being scan resistant, right? So if something is scanned, it's accessed only once, and then it can like fall out of the cache faster than things that are accessed have been accessed multiple times, where we're like, well, it's been accessed twice, at least twice, so it's like more likely to be accessed again versus something that's only been accessed exactly once. And maybe that kind of thought process will help when like trying to figure out what it should really be doing.
No, I actually read original paper about ARC cache, but I haven't found that part in there. Like it looks like it's based on assumptions that MRU and MFU lists shouldn't overlap too much. But the fact is, if we are doing a lot of MRU hits, like we end up with buffers that are pretty recent, but they are in MFU list. But well, potentially they should be theoretically in both because they are still recent. And problem that ArcP is practically measured in bytes, lengths of time, how long shall we keep recent data in cache with hope for them to be reused. And from that perspective, when we are promoting something to MFU, ArcP should remain the same because distance haven't changed, obviously, from the fact of promotion. But on the other side, since we promoted ARC, there are just less data ended up in MRU, ArcP should be reduced. And there is controversy. And like I described mechanism, how could we temporarily reduce it, but then restore it when actual eviction time will arrive. So I think it should be at least a closer much an original idea with not so much plot.
Yeah, I read the original paper like a long time ago, and I totally forgot that that's how it was originally proposed. But yeah, that's definitely not how it was implemented in terms of like a block can only be on one list at a time in the actual implementation. In our implementation.
No, it doesn't say it should be on both. That's just my assumption because idea of MRU is just we have X amount of data which are recent that we may reuse. But when we promote from data from MRU to MFU, we remove them from MRU. And just the distance, if you still try to measure it in bytes of cache size, just bytes of sequentially read from disk are not the same as bytes as currently in cache because we've removed things out of MRU list. And after that, if we start to do more reads and add more data to MRU, should we read the previous or should we keep them? Because right now it may happen that, okay, we have huge MFU because we just promoted a lot. So we start reading and that MFU immediately wiped out because of our ArcP still huge. While there's just no data for it.
Yeah, it does seem like the MRU MFU split can become very far out of balance, and it's like it can get stuck there, and then you have the weird behaviors you're talking about are even more accentuated.
Is that adjustable in any way? I put a comment in chat there for what it's worth.
I saw the comment, but I couldn't read it in time.
That's okay. So Matt, you mentioned what I'll call sensitivity to a scan. If data is passed over n number of times to be eventually cached, is that adjustable in any way, or is it just hard coded?
I mean, it's not about it only cares about is it scanned over once versus multiple times.
Okay.
So there's no like n, there's no hit count in the arc, like a per block hit count in the implementation.
Well, isn't there? We
actually
keep the count in the MFU, right?
We have counts for all the states, but they are only statistical ones. They are not used for anything.
Yeah.
Maybe we could.
I don't think that there's a count per block.
It does.
Oh, it does have a per block count?
Yep.
But we don't use it for anything. Interesting.
Well, other than to differentiate that, oh, this should go over to the MFU. And I think the MFU algorithm uses it to decide, if that counter isn't going up, that it is more evictable or something, but
I don't think so.
MFU algorithm just based it on simple fact, okay, we are now in MRU, we got another hit, so we are promoted. It doesn't care about counters. Yeah. But we do have counters for every state, or counter for number of hits for every state. For L2 arc, they are in L2 header. For other states, they are in L1 header. So we are spending some memory, but they are reported only through some stats interfaces, but not used for any math.
Yeah, that sounds like a waste of memory then, right? If we're saying that every block has a hit count, I mean, we tried to be pretty efficient with the memory usage in the arc header. I'm surprised that we didn't do that.
We were explicitly hard on L2 header. For L1, we were not so much. But...
Interesting. Yeah, that's true. That's true. Yeah, I think there's probably a lot of improvement that could be done here. I think it's tricky because we don't have like some like reference workload that we can feed into it and then measure the hit rate and then like try a different algorithm and then feed in the reference workload and measure the hit rate.
What prompted my question was, say, video editing, where you might have very significant metadata that applies all the time, but then very high flyby actual media data that you don't want to attempt to cache in any way.
No, for media data, you should never get ghost hits. As a result, you should never grow MRU much. So your MFU should stay, or MRU should stay pretty small and don't care about wiping out ARC, while MFU should be sufficient to keep all your frequent user data. That's the idea. That I'm not sure. I think like as I mentioned, there could be mess between distribution of data and metadata. We have in addition to MRU MFU. That's where it could be messy, and I think it's half broken now. But I need to think in which way to better solve it. Either I think it could be tracked, the distribution data, metadata could be handled through the same mechanism of ghost caches, ghost headers, or we need to at least unify and don't track separately data metadata distribution for ghost states at all for proper eviction, because right now it's broken. So there was PR actually somebody created to completely remove distribution on data metadata in Arc, but somebody was screaming loud, no, it's bad, it's bad. So I'm still not sure it's bad, but I need to look closer.
Thank you for those explanations.
Other questions or topics?
Yeah, I guess just looking at it quickly, the L1 buff header might actually have a bunch of more stuff than maybe we need. We have hit counters for MRU and Ghost MRU, MFU and Ghost MFU.
Yeah, there's
And
lots of
then
stuff in there.
a clock T for the last time it was accessed, although we do use that. I don't know how much we use the ghost hit counters though.
Those are exported somewhere and used by somebody's profiling tools or something like that, debugger tools, but they are not used for real life. Only access time is really used for promotion from MRU to MFU.
Right, and even the byte swap is an 8-bit, and I think it can only have a Boolean value, right?
You
Maybe
mentioned
it can become
access
a
time.
flag or something.
Is that POSIX access time or internal to ZFS?
It's a clock T.
It's internal.
Thank you.
Yeah.
Thank you.
I'm actually wonder why so small distance between hits which are counted as MFU. It's now it's like 60 milliseconds, 64 milliseconds, something like that. Why so small? Like sure, like because I think on sequential read we may end up reading indirect blocks multiple times within the time, considering typical some slower disks and 1,000 block pointers per indirect block. It means like more than 100 megabytes per second. There are potentially disks that are slower than that, and they will probably get indirect blocks promoted to MFU. Just not sure it's good or right. Matt, do you know where that value comes from?
I don't know.
One seems pretty arbitrary. Like,
Ancient times.
yeah, it's very likely that a much higher value before we promote it to MFU might actually result in better results. Because if you access it twice really quickly, but then don't use it again, it's
it's
not that helpful.
if you access it quickly, it's still in MRU and it should be fine staying in there. So I was thinking whether bigger value could be better. It actually was confusing because comment was talking about 128 milliseconds, while actual value, if I read correctly, means 64, like 1/16th of a second. So it's not even self-consistent. So I was thinking whether bigger value should be better.
Right, and it depends how it's measured. I know with the old scrub timing stuff, the Illumos clock ticked at 100 hertz and the FreeBSD one at 1,000 hertz, and it meant the tunables did very different things with the same value.
Yuck.
Yeah.
I think it's HZ divided by 16 or something like that. I don't remember.
Yeah, I think we fixed all those several years ago, but I remember that.
Still thinking about uncached prefetcher as one of possible solution for evict data that will never demand access it. I'm thinking adding one more arc state, something like uncached or something. I'm not sure about name, but the idea is just to drop there all the buffers that should be freed after like 1 second and create separate reclamation threads that just go a couple times per second and free everything that remains there. That's one of my ideas. Alternative idea I had just put them into debuff cache, since I expect them to be physically contiguous and there should be no duplicate memory. And then on eviction from debuff cache, that could be evicted also. But from the prefetcher perspective, since it doesn't use debuff cache right now, That would be a bit awkward. But I think it would be good to allow uncacheable data to stay in debug cache. That would allow like sub-block reads to be still cacheable. Because right now it happens weird, like if you have block 128K but read 64K at a time, you'll get evicted and read. It's inefficient. So I'm thinking about allowing uncacheable data to stay in debug cache and be evicted from there normally.
That might be reasonable. Would do you think that it would be sufficient to say like if you did a sub-block read, then we'll keep it in the debug cache? But if you read the whole thing, then we'll kind of assume that you got everything you could need, and then we would not cache it in the debug cache.
Well, I had such idea too. It's just that information is not available at that point of making decisions. It should be passed through some additional flags. But yeah, I had such thought too. It would be good probably.
Cool, that's a good brainstorming. Powell, I saw you unmuted there for a sec. Did you have another topic to discuss?
Yes, I would love to get some people to do the final review of block cloning. I think everything is addressed. Not everything is addressed in optimal way, but I think we can definitely move forward and basically work on some optimizations later. This is mostly stuff like cloning across across two different data sets. When we fsync such cloning operation, now we will just wait for transaction group to be synced instead of using ZIL. But this can be added later, exploring your idea, Matt, to using ZIL claim. Yeah.
I don't remember was it commented I was going to, but I think full transaction commit on every copy request we think is too much. What if files are small and we just for file of 100 kilobytes or even a few megabytes will commit transaction group, which will mean many megabytes of writes and cache flashes and quite expensive. Maybe there could be some threshold before which we just report we can't do it or something, just to fall back to a regular copy.
I think the best idea is to just do ZIL claim, but it needs some work.
No, yeah, obviously. I'm just at this point, like I understand that transaction commit is easy to do, but it may be unacceptably slow. Like, wouldn't it be better just return error and let fallback code to do manual copy? I think it would be much faster than waiting for commits. Yeah.
Well, in that case, you can just simply don't change the code in the VFS to not allow, to not call the file system copy file range and just use generic file range, generic copy file range. So this can be disabled for now until the ZIL claim is used for that.
Oh, I just like it to work for within one range, within one mount point, within one data set. And when crossing data set, okay, it will return error and let fallback code handle it.
But for now, VFS prevents that. At least on FreeBSD, on Linux, I think it will allow, it will call into ZFS. We could return an error then.
Yeah, you could argue like maybe the first thing that gets integrated is like there's a flag that says that lets like a tunable that lets you choose between you cannot zero copy between data sets, or you can zero copy between data sets, but it's but you get the TXT weight synced if you fsync it. And maybe the default is just you can't zero copy between data sets in the first implementation. That way, like there's less of a sharp edge for these initial users. And then like once we do the ZIL claiming or some other solution for the fsync, then we can make that be enabled by the zero copy across file systems be enabled by default.
I would actually even opt for a third option where you simply ignore fsyncs for cloning, because I think that the most common use case would be to clone large files and not small ones. So in this case, I personally I would just do that on my pools.
But for large files, you can probably afford to do the TXT weight synced after the whole file is copied, right?
Yeah, I think we could add some threshold. I don't know what it would be, like 100 megabytes or gigabyte, after which I'll allow it and wait for transaction commit. Probably it wouldn't be that bad. While for small ones, it makes no sense.
But for small ones, you would like us to do nothing, or
yeah, fall back on copying the data, right?
Yeah.
Okay.
That way it could be logged, in the ZIL like normal.
Yep. Well, it's okay. It's double write. It's extra space usage, but it should be so much incomparably faster that it should be better, I think. I just had a thought. What else? In case of copying from snapshot, as mentioned, good use case, would it be counted as separate data sets or not? Because it would probably be safe to copy data out of data set because they are stable. And the only way for space to be freed is actually deletion of the snapshot, which means a transaction commit by definition, I think, and then we should be safe.
Well, I'm not sure if we will be safe, because you can still destroy snapshot without mounting the file system, right?
Yeah.
And replaying the ZIL.
Yeah, that would, like, unfortunately, I don't think that's the case because of what he mentioned. Like you could do the like copy file range from the snapshot and then lose power and then come back up and not mount the file system, and so not play the ZIL and then like delete the snapshot and then later on mount the file system, and then it plays the ZIL and the ZIL says, oh, refer to this block that happens to be from the snapshot that was deleted, which would be bad.
Yeah, true. I was thinking from wrong direction. Agree. That's pity.
Unfortunately.
Yeah. I can definitely do tunable. I can also look into ZIL claim. There was, I think, one complication with ZIL claim. It's maybe it's not a huge complication. I didn't read into the code too carefully, but there is some handling of rewinding the pool. If you import the pool and you want to rewind to some other transaction group, you don't want to replay or claim some of the records.
That should be fine, right? Like if we're not in those cases, we're discarding the ZIL. So but like when you rewind to an old TXG, we're also discarding the ZIL and not using the ZIL. And so the fact that we don't claim it and we don't replay it. So the fact that there's entries in those ZIL records that refer to blocks that we're not sure if they really exist doesn't matter because we're never going to play them, right?
I actually Why shouldn't we replay a log in case of rewind? It just import previous transaction. Previous transaction has its previous ZIL. So a replay of it should give us more up-to-date state. It should be good. I think it should be replayed always, or I missed something. Of course, if we're rewinding too far back, blocks could be overwritten by something, but from the point of that TXG metadata, that should still be allocated, valid, and everything. So I don't think why rewind should be a problem.
I think I agree with that, and also, if we discard the ZIL, then that is also not a problem, right? I think that there's like a flag that you can do like rewind and discard the ZIL or whatever, and that should also work.
But for me, the rewind operation was mostly like a way to recover the pool when pool is in some kind of like corrupted state, right? So I would think that you don't want to replay any data behind some point, because you don't really trust any data beyond this transaction group or something like that.
The stuff that was logged in that transaction group is still in that transaction group that you're trusting or trying to trust.
You're not going to rewind beyond that transaction group further ahead. There should be different logs for each TXG, if I remember it right. I understand right.
Yeah.
So can we try to like agree on some version which you guys would find mergeable
Well, I think
before ZIL claim is done? Tuneable would be okay.
Yeah, I mean, my principle is that like the behavior out of the box should be correct. Like we shouldn't just be ignoring ignoring an fsync. And it would be nice if the behavior out of the box didn't have like extreme performance sharp edges where it's like, oh, if you fsync it, then like most fsyncs take on the order of milliseconds, but then some take on the order of seconds because they happen to have, because you did a copy file range, right? So the thing I was suggesting where it's like, normally the behavior is that like you can't copy file range across data sets, then you don't have to worry about fsyncs of copy file ranges across data sets because they don't exist. Alexander, does that work for you as well?
I think if we would set tunable to like 1 GB and for copies above 1 GB, we always do transaction commit. That I think should be acceptable. And for anything below that crosses, we should return error and do manual copy. That would be okay for me and should be trivial to implement.
That's fine with me too. It sounds slightly more complicated than what I was suggesting, but sounds semantically,
but still easy enough. Yeah. Okay, but just so you know, there is one more case where we we wait for transaction sync, is when we try to clone blocks that were created in the same transaction group. So I just wait for transaction group to sync with this operation. We could also fall back to the copy, but well, again, it depends on the perspective. I know that IX have a lot of storage available, but I would guess there are some use cases where you want to save as much storage as possible. So
no, saving is good, but again, what happens if we have large ZWall with multiple concurrent operations? One VM doing a lot of writes, other VM doing who knows what, but some other like VMware itself will try to do copy, not VM cloning, and since like granularity of the decision is a full ZVol, it may end up syncing them for every few megabytes. That's also quite expensive. It would be nice, I think, if the code could differentiate it more fine-grained, like whether this data it copies actually overlap, because having offset dirty is quite big one.
But if you copy stuff in parallel, I think that you are okay. Only one stream will be frozen for a bit.
No, like what if one process doing a lot of writes while other process trying to do block cloning on completely unrelated part of the object, so they're not overlapping, not conflicting, but since the first one always creates dirty blocks, or I misremember how it's implemented. I think it was like if we have dirty record for anything, for object, practically for the wall itself, right?
So actually, for ZVol, it's not implemented yet. It's not attached.
No, there's
to
no interfaces, but yeah, we've discussed it would be good. But no, potentially could be a file with same assumption. I don't know how often is that. Just ZVol example is the most prominent.
I mean, the checking of whether you're copying file, if you're doing copy file range from something that was modified this TXG, the granularity should be on a per block basis.
Yeah.
Is that how you implemented it, Powell?
Yes. Yeah.
Is it per block? I think it's also if we have dirty record for anything. Oh, like I forgot.
Are specific to blocks.
No. If so, basically, I want to clone a block, and there is dirty record for this block, which doesn't have.
Oh yeah, then I have no objections. Then it should work. I just somehow thought it's per object. But if not, then it should not be a problem. I don't think it should be at least very specific workload. Pretty weird one. I don't think I have one as such.
Yeah, I mean the TXG weight. I think I would argue that yeah, that is a weird workload. It's probably unusual. And if you hit that unusual workload, let's fall back on copying the data rather than fall back on TXG weight synced, because the performance implications of the TXG weight synced can be pretty extreme. I think it's probably, like in my mind at least, I'm thinking that the copy file range is kind of advisory. Like there's no guarantee that it's going to save you space. It's like most of the time, in most circumstances, if you're using it kind of the way that we expect you to, then you're going to save a lot of space. But if if the stars didn't align, the data that you're coming from is dirty, or what is different data set or whatever, then we're going to fall back on, or some layer here is going to fall back on just copying the data. That's kind of my mindset. Is that reasonable for the use cases that you're thinking of?
Who, me?
Yeah.
Yeah, it is reasonable, of course. Actually, copy file range does have a place. You can provide some flags. Currently, the standard actually doesn't define any flags. I think there are some ways on Linux to, or I'm not sure if there is, but I could imagine a flag which says that just clone at all cost. So don't care about performance. And the default behavior would be to be just performant and do whatever is quicker, right?
Yeah, I guess I'm coming from the perspective of like most of the point of this is performance, like saving, copying the data from, like reading and then writing the data to disk, versus space savings at all costs. Because if you wanted space savings at all costs, you could always use dedupe.
Yeah, that's reasonable. Like I was actually coming from the perspective of but this was also different. That my initial implementation was, my perspective was to always clone the data and save the space. But then I was also implementing dedicated system calls. So you could, so that was the purpose of the system calls, right? To save the space. But now copy file range, as you mentioned, it is advisory, right? So if it's, this system call is not there to guarantee space savings, right? It's there to actually speed up copying. That's the purpose of this system call. So that's, yeah, that's reasonable.
Yeah, so then in that case, I mean, I feel like getting this integrated, what it, you know, getting this integrated sooner rather than later, with the perspective of like, it's going to speed up a lot of file copies, but not all of them, would be a reasonable approach. And then like later on, we can add more circumstances where the copies will be accelerated by this, depending on, you know, customer needs.
Yeah, definitely. There is also another case that should be optimized, where you do unalign copy file range. So for now, I just return an error, but we can definitely implement copying just the unaligned fragments and cloning the rest.
Yeah. That seems
The
fine.
implementation is a bit more complex than that, because we probably want to do that under one vnode lock, and the generic copy file range, at least we have in FreeBSD, assumes it's not called as a part of different operation. So it will log vnodes on its own. So I cannot really use that atomically with just copy fragment using generic copy file range and clone the rest under without dropping the locks.
Sorry,
Cool.
guys, I need to leave. Good luck, Paul, with that. Would definitely be good to see and integrate it. I need to
Thank you.
do other things.
Yeah, it looks like even mentioning the indirectly mentioning the possibility of an early meeting has caused us to use the full time. But I'm glad we had this good discussion. Thanks everyone, and we'll see you in 4 weeks.
Thank you, guys. Bye.